Hello, this is Miss Hawkins. Today we're going to start topic 4 in your Envisions math book. It starts on page 165. Before we get started, go ahead and get your math book out and go to page 165. You can pause the video now. Okay, you see there is a problem with Javier, and he has some posters he's going to hang up at his parents' movie theater. Um, So we're going to talk about that and try to figure out the thickness of the posters when you stack them up. Also, if you could please look at the screen, here we have our learning objectives for today. Topic 4.1, that's what we'll be covering. Number 1, when multiplying decimals by powers of 10, that means 10, 100, 1,000, 10,000. We're going to use the pattern of zeros to know how many places to move the decimal to the right. We kind of talked about that in topic 3, but it's, for instance, 9 times 10 is 90. So you move the decimal from 9.0 over 1 to the right, so it'd be 90.0. When multiplying decimals by 0.1 or 0.01 or 0.001 or 0.0001, use the pattern of zeros to move the decimal to the left. So when you times it by 0.1, you're actually going to be making it smaller because 0.1 is actually 1/10. So if you had 9 times 1/10, it would be 0.9. So you're actually taking 9 and dividing it into 10. And then 0.01 is 1/100th. So it'd be 0.09 or 9/100ths. And 0.001 is 1,000th. And 0.0001 is 1/10,000th. So it's a lot to say. So in this video, I'll probably say 0.001 instead of 1,000th, but that is actually what it is. Okay, you should be on page 165. And let's go up to this page here. Okay, you see 165 at the bottom. All right, and scroll up, and you see Javier is helping his parents put up posters in their movie theater. Each poster has a thickness of 0.012 inches. How thick is a stack of 10 posters? So one is 12 thousandths of an inch, or 0.012 inch. But if we had 10 stacked up, how thick would they be? How many inches? If we had 100 stacked up, how many inches? And if we had 1,000 stacked up, how many inches? During this exercise, you can actually do this by yourself. There's no wrong answer. Um, we're going to actually solve this problem for you, but if you ever wanted to just do this on your own just to practice, that would be fine. Now, first I start with a problem I know so I can kind of get a handle on this. If it was 12 inches for a piece of paper, which actually a piece of paper would not be that thick, and I timed it by 10 posters, how thick would that stack be? So 12 times 10, if you remember from last topic, 12 times 10, I just add a zero here on the end. So it'd be 120 inches thick. But that is really not realistic because the piece of paper is very thin. It's not 12 inches thick. But what I did was I moved the decimal over to the right and put a zero there to hold the place. So now I remember if I times something by 10, the number gets larger. I move the decimal to the right. That'll be important because later, when we times something by 0.10, you actually move the decimal to the left. But let's stick with this. I'm going to erase this so we don't get confused. So what is our original number sentence? We take the one piece of paper, and how many inches thick is it? It's 0.012. I'm going to times it by 10 because I have 10 stacked up. So I would need to add 0.012 plus 0.012, or just do it 10 times. And we need to find this answer. First of all, I'm trying to remember what we did last time. We times it by 10, so I know this number is going to get bigger. So, and last time we moved the decimal to the right this way, so I'm going to do that again. And how many places do we move it to the right? Well, I have 1 0 in 10, so I'm just going to move it one place to the right. That's what we did with the 12. We just added a 0. Here, we just moved the decimal place to the right, one spot. So now my answer would be 0.12. Let's try this again and see if we can keep up with this. If I had 100 posters, so he has a really big movie theater. Again, each one is 0.012 inches thick. That's actually 12 thousandths times 100 this time. Okay, so before my number was 0.12. You think the number is going to get bigger? It should, because I have 100 sheets, not just 10. And how many times or how many place values do I move my decimal? I count 2 zeros here, so I'm going to move it 2, 1, 2. And I'll put it right there between the 1 and the 2. So my answer is 1.2. And actually 1.2 is larger than 0.12 because this isn't even an inch. 0.12 is not an inch. So 1.2 is a little over an inch. Okay, so if I had 1,000 posters, do you think it's going to be greater than 1.2? I had 1.2 inches when there were 100 posters stacked up. So if I had 1,000 posters stacked up, I'm guessing it's going to be even bigger, an even taller pile. So I have 0.012 inches for one sheet. I have 1,000 sheets, so I need to do this 1,000 times. 0.012 or 12 thousandths. Okay, so what would this equal? Well, when it was times 10, I moved the decimal to the right 1. When it was times 100, I moved the decimal to the right 2. I kind of look at the zeros. When it's 1,000, I move the decimal to the right 1, 2, 3. There's 3 zeros, and I moved it to the right 3 times. Then I'll put my decimal right there. So the answer for that would be 12. If you want to, you could put 0.0. It doesn't really matter because that just means nothing comes after 12. So 12.0 inches thick. Now I'm going to show you a little trick here since we're at it. Let me erase this. 100 and 1,000. And I'm going to put in an exponential form. Instead of putting 100 here, I'm going to put 10 to the second power. That means it has two zeros. Instead of putting 1,000 here, it was 10 to the, how many zeros does 1,000 have? 3. And how many zeros does 10 have? 1. So 10 to the first power is 10. 10 to the second power really is 100. 10 to the third power is 1,000. And where they get that from is 10 one time is 10. 10 times 10 is 100. 10 times 10 times 10 is 1,000. So that's how we did that. So we actually mastered that problem. We did it backwards and forwards, and you did a great job. All right, let's go to page 166. Awesome. So now it sounds like she's going to make a cake. She's a baker. Let's read what she's doing here. A baker has a 10-pound bag of pecans and a 100-pound bag of flour. How many cups of each ingredient does the baker have? Um, so I guess they weigh different. So if I had a pound of flour, I put it on a scale, I would have to get 3.63 cups to make a pound of flour. But pecans weigh a little less, so I would need more pecans to make a pound. So I would need 4.2 cups to make a pound of pecans. So we're going to learn how multiplying decimals is like multiplying whole numbers. And you can use multiplication to join equal groups. Let's see what they're talking about. Right now, we're just going to kind of look at this chart. We just kind of talked about this. 10 in exponential form is 10 to the first power. They show us that 3.63. Now, wait a minute. I need to go back up here. I forgot already. Okay, they're talking about flour. 3.63 cups is a pound of flour. So 3.63 times 10. Now you see we moved the decimal to the right. Let me go ahead, use a different color this time. So we times in something by 10, so we move the decimal to the right. So they got the same thing, 36.3. I would like you to take a second and think about this. What is 3 times 10? 10, 20, 30. 3 times 10 is 30. So this makes sense. 3.63 times 10 is 36.3. If you got a crazy answer like 3,000 or something, you would say 3 times 10 is nowhere near 3,000. I did something wrong. But 3 times 10 is 30. So 3.63 times 10 is 36.3. So that does make reasonable sense. 100 in exponential form is 100 to the second power. So there's going to be that 2 zeros. I'm going to go ahead and move the decimal 1, 2 places to the right. 363. You can put your decimal right there. I could have put a decimal right here if they wanted to. And 3 times 100 is 300. So yes, 3.63 times 100 is 363. Here we go with the 10 to the third power. I'm going to move it 3 times over 1, 2, 3 place values. I'm going to put a 0 here to hold my place value. So the decimal still goes right here. I moved it over 3. So yes, that answer is 3,630. You know that 3 times 1,000 is 3,000. So yes, 3.63 times 1,000 is 3,630. Okay, so down here we're talking about, so 3.63 times 10 to the second power, or 100, is 363, and 4.2, where they're talking about pecans, times 10 is 42, because you just moved it over one time. Okay, the baker has 363 cups of flour and 42 cups of pecans. All right, so they did the 10-pound of pecans and the 100 pounds of flour, 10 pounds of pecans right here, and the 100 pounds of flour. Okay, let's continue the pattern to find the number of cups for 100 pounds, 1,000 pounds, or 10,000 pounds of pecans. So we're going to the 4.2. Sometimes I look back up here to make sure. Yep, they're talking about pecans now. 4.2 times 100. We're just going to move this decimal over 2 times. You can do the exponent of 2 or the 100 with the 2 zeros. Same difference. And then I'll put my decimal. This is 3. So how many times do I move the decimal to the right? 1, 2, 3. Now I need 2 zeros here. And then I always look over and say, yeah, I got it right, just like they did. Now here's 10 to the fourth power. They're talking about this 10,000 here. 1, 2, 3, 4 zeros. And I move it over. 1, 2, 3, 4 spots. So I need to put 3 more zeros here to hold my place value. That's 42,000. And if you think about it, 4 times 10,000 is 40,000. So 4.2 times 10,000 is 42,000. So 100 pounds of pecan have 420 cups. 1,000 pounds of pecans has 420 cups, and 10,000 pounds of pecans has 42,000 cups. Convince me. Use structure. Complete the chart. What patterns do you see in placement of the decimal point? So we are doing this in class. If we take 1.275, which is 1 and 275 thousandths, times 10, I'm just going to move this decimal over 1 and make it 1, 2. I'll let my brain work now. That actually is 12.75, or 75 hundredths. Now here we go times 10. I'm just going to move this decimal over 1 and make this 200. Oops, kind of a fancy 2. And 60. And then point 14 hundredths, or point 14. And then here's my little 0.4 times 10. So you just move the decimal over 1. So I'm just going to put down 4. You can put down 4, or if you want, you can put down 4.0 just to remember you had to put that decimal after the 4. It was before it. You moved it over 1. Now it's after it. Now here I have 10 to the second power, which is, don't forget, that means 100. 2 zeros, but you already see the 2 right there to know how many places to move it over. What about 10 to the third power? 3 zeros. So we're actually using the pattern of zeros to show us how many spaces to the right we're going to move. So if I move it over 2 times, we go 1, 2. So that would be 127.5. Now that we're kind of on a roll here, if I move it over 1 more, I know it's going to be 1,000 now. 275. Sometimes I just put the numbers down and then I figure out how to say it after, because we got the pattern right. Now here, this 26.014, if I moved it over 1, we got the 260. I'm gonna move it over 2 and put it right there. Okay, so now it's 2,600, 1 point. That doesn't look good. Hold on 1 second here. Let's erase that so everybody can see. Okay, so I moved it 2, 1, 2. So it goes between the 1 and the 4. So let's try again. 2, 6, oh, 0, 1.4. A little messy. Maybe I'll try to fix my 6 up here. Okay. Now, if I have to move it over one more time, I'm going to have to move it over on the other side of the 4. So it's going to be 26,000. And that makes sense. 1,000 times 26 is 26,000. $14. Okay. Took me a while to think of that. And then we put the period, the decimal right here. So that's right. And then you count over 3. 1, 2, 3. And you can put your comma right here if you wanted to remember that's 26,014. Now down here, we moved it over once for 10. Then we need to do it twice for 100. Then I would add my 0 there. So this would be 40. And then one more time. Now I need 2 zeros, so that'd be 400. Again, you can always put a decimal at the end if you wanted to on these just to remember that you had it, but you really don't need it anymore. Okay, let's work on some problems, and then I'll let you get to your homework here. Um, Here's one, number 20. Let's do this one together. Let's use a different color. You gotta have fun when you're working online. So Jefferson drew a line 9.5 inches long. What's the first thing I'm gonna do? First thing I'm gonna do is draw a line. It's probably not gonna be that long, but I'm gonna draw a line right here. And sometimes in math they like to put a little stop mark. There's a stop, and here's the start. Little. Now this is 9.5 inches. Okay, point and then 5. All right, so now I know what Jefferson did. He did a pretty good line. But here comes Brittany. She drew a line 10 times as long. Well, it didn't say it's 10 inches, it's 10 times as long as his. Okay, so she started her line here, and she just went way off. 10 times as long as him. All right, so how are we going to find out how long is her line? So her line, and let's call this a number sentence, is 10 times as long as Jefferson's. So Jefferson's was 9.5, and hers is 10 times as long. So I kind of already know I'm going to times his by 10, and that's how long Brittany's is. So again, I'm making his line bigger. So I'm going to move the decimal to the right one time. There's 1 0. I'm going to move it to the right one time. Okay? So that's going to be 95.0. Or you could just say 95. So her line is 95 inches long. His was 9.5. Okay? And that makes sense because 9 times 10 is 90. So 9.5 times 10 is 95. But here's the problem. It didn't say how long is Brittany's line. It says what is the difference in length between the two lines. That means how much longer is hers. So actually I'm going to have to I want to see how much longer it is. So I'm kind of looking for this extra piece here. Let me use a different color so we can see. How much longer is it? So hers is 95 inches long. And then I need to know how much longer. How farther did she go? She really did go a lot farther. So how would I get that? Well, I would take her whole long line, 95. Remember, hers started here. It ends here. And then I'm going to take off the part that Jefferson drew, or basically how long Jefferson's line was, to see how much longer was hers. So I'm going to do 95. And then I'm going to minus his line, 9.5. Now here, we are going to use a calculator. I'm just going to show you though, when we start doing this in class, you need to line up your decimals. And just kind of watch what I'm doing. Don't freak out, but that's what we're going to do. You have to line up the decimals because you have to keep the place values the same. This is the ones place, this is the tens. You have to keep them the same, and the decimals help you do that. So I even bring my decimal down here so I don't forget. But please get out your calculator and you will find that the answer is 85.5. So her line, yes, it's 95 inches long, but it's 85.5 inches longer than his. So she didn't go 95 inches longer than him because he went a little ways. He went 9.5, but then she kept going 85.5 inches longer. Okay, so that was awesome. Good job, Brittany. Here is the last problem we're going to do today. We're going to do number 22 on page 168. Okay, we're going to choose all the equations that are true. So this is one of those tricky questions where you wonder, is it going to be one? Are two of them true? Are all of them true? Why do they do this to us? Well, it is a little bit tricky. So you kind of are doing 5 problems in one. So first of all, um, well, I'm gonna stick with purple. It's my favorite color. So choose all the equations that are true. Okay. So I have to kind of settle my brain down and realize I thought this was one problem. It's really more like 5. All right. So 4.82 or 4 82 hundredths times 1,000 is 482,000. I want to say yeah, because it looks right, but let's check it. So there's 1, 2, 3 zeros. I'm going to move my decimal 3 place values over. 1, 2, 3. So then I will put a 0 here. So my answer should be 4,820. Oh, no, no. This one has too many zeros. So this is not right. This is not right. Okay, so let's go to the next one. 10 to the second. I'm going to move this over 2 then. 1, 2, because there are going to be 2 zeros. 482. And put a decimal. Do they have, oh, they do have 482. So this one is correct. Yay. Here is 0.482 or 482 thousandths times 10. Well, I just move it 1 over and put my little decimal between the 4 and the 8. Do they have their decimal between the 4 and the 8? No, they kind of messed up. Sorry about that. All right, 0.482 or 482 thousandths times 10 to the third. I'm looking at that magic 3 there for 3 zeros. 3 moves to the right. 1, 2. 3, I should put it right after the 2. 482. And then a decimal. Is that what they have? Yeah, that's right. So I'm going to go for it. Let's do it. Now here is 10 to the 4th power. I have to go over 4. This is actually 482 10,000s. 1, 2, 3, well, 4. That's going way after the 2. So it's right after the 2 right here. Do they have 482? No. Nope, they got it mixed up. So even though your number might look close, 400 is way different than 4,000, believe me. All right, so that was page 168. Here's our homework practice on page 169. Okay, if you guys can do your homework on 169. Now, here's something they do in the book that, well, all of a sudden we start talking about timesing things by point 0.1 and 0.01 and point 0.1 and 0.01. So that is different than times 10. So I'm going to give you a little lesson in this right now. And I'm going to tell you that if you caught on to what I was just saying, you should kind of understand how to do the 0.01 instead of 1 and the 0.001 instead of 10 and all that. You move the decimal to make your number larger. You move it to the right. Okay, so you move it to the right. You add the zeros, whatever you need to do. If you need to hold your place value, you move it to the right. But guess what? You want to make it smaller, and you're times it by a tenth and 100th. You actually move it to the left, and then you make it small. So moving it to the right makes it larger. And you kind of think of that, if you have 9, and then you times it by 10, and you move your decimal to the right, and you get 90, that's larger than 9. But if you move it to the left here, you're going to actually make it smaller, so you're going reverse. So it gets a little crazy, but it's a game. Math is kind of a game that we will win. So here's by point 1. So I'm going to move it. I'm going to move it over 1 to the left, and put the decimal right here. That's point 1. And it's 1 place value over. And then that's what answer they get. So that was right. Here's 0.01. This one is over 2 this way, 2. So I'm going to move the decimal the opposite way. 1, 2. I'm making that number smaller because that is 100th. So I'm going to make that 42 small. It's only 100th of it. So I get 0.42. And that looks right too. Here's 0.1. That's 1 over. So I'm going to move this decimal 1 to the left and get 42. Oops, they got 4.2. So nope. Here, this is over twice. It's the decimal. I would have to move it over twice to get to 1. So here I'm going to move this over twice to the left and actually have to put a 0 right here and then put my decimal. So it'd be 0.0042. That's not the same thing they got. They got 0.042. Now here my decimal is, I would have to move it over 1. To me, this is how I think about it. 1, 2 to get to a 1 to the right. So I'm going to move this over 1, 2. And put a 0 here to hold my place value. And then put my decimal here. That is actually 42 thousandths. 0.042. Well, they have 0.0042. So actually only the first two are correct. This is on page 170. So let's just wrap this up with a little practice on this. If I have, let's go back to my 9 times a tenth, and that's 0.1. What would the answer be? It's not going to be 90 because I actually want a tenth. This is 0.1. That's not 1. 9 times 1 is 9. So times 0.1, I'm trying to get a smaller number. So I'm going to take my decimal. That's where the decimal is over here. It's just hiding. And since this is one number over from the decimal, I move it one to the left. And so my answer would be, I like to put a 0 to save the place value, 0.9. Okay. And the reason I do that is, if I move this over to the right one, it would be 1. So I don't know. So I move it to the left one. So I move this to the left one. Because that's how many place values it's over below a 1. Let's try one of these hard ones like 0.5, half an inch of something. And I'm going to make it even smaller. I want a tenth of that. Maybe a hundredth of that. I don't know. I just want something just so small. 0.01. That's a hundredth. Oops. Equals. Well, okay. So you see how I don't mean to freak anybody out, but 0.01 is 2. I counted over. I got 1, 2 that way. 2 to the right if I wanted to make it 1. But it's not. It's 2 over. So I'm going to move this decimal over to the left. 1, 2. I would have to add an extra 0 here to hold the place value. And then that's where I would put my period, my decimal. So I'm going to put 0.005. So however many place, I just want to emphasize this. I'm going to take another color and then I'll let you guys work. But when we're doing this kind of, I think we have the tens down, but these tenths and hundreds and the thousandths, we're timesing something and making it really small. I just look and say that's over 1, 2 spaces. You can say place values. It's over 2 place values, a tenth and a hundredth. So I'm going to take my decimal over here. I'm not going to move it to the right because that makes it larger. Remember? Nope. I don't want this to turn into 500. I actually wanted it a hundredth of it, like a small number. So I'm going to move it to the left 2 spaces. 1, 2. And that's how I get my answer. So when you see these times 0.1 and 0.01, move it over to the left. When you see it times 100, when you see it times 1,000, move it over to the right. Okay, so you moved it over to the right 3. 1, 2, 3. And you would have got 360,000. So that is the difference. All right. So we've practiced some. I will send the homework to your parents so you can work on it this week. I'll probably put out another video later this week, maybe Tuesday. And then we should be done with topic 4.1, 4.2, and 4.3 this week. So we really just need to practice, and I think that you guys will get it. If you have any questions, you can please call me or text me. I don't mind talking on the phone. If you have specific questions about a problem that's bothering you, you can tell your mom and she can text me, on page 168, problem 2 and 3. I just can't get it. I can make a video for you and put it on YouTube and help you with that. And if other kids in the class or that are doing packets have the same problem, we can talk about it. If they have other problems, we can do those too. So basically, if you have any questions, reach out to me any way you can, and I'll answer your questions. I love helping. Math was really hard for me when I was younger, so I've had to think about it in different ways. I do like this book because it gives you some real world problems. So I'm very eager to help you. So have a great day, a great week, and I will talk to you soon. Thank you.